Hello my dear friends. Now in this lecture we will discussing about concept of enthalpy 1. See, we take one example like that. Example number 1. It is like that. A constant pressure quasi a constant pressure quasi a constant pressure quasi static equilibrium process for a simple compressible system, right? Now let us a piston, let us a cylinder and a piston, this is a piston and this is our system, this is our system. Let us a piston moving in a quasi-static equilibrium process. So the pressure inside the system remains same. The same, why? Because the resistance pressure, that means the atmospheric pressure and the weight of the piston will always same, so inside pressure also will not be changed if it will move in a quasi equilibrium process. That means why it is moving in a quasi equilibrium process. So this is your piston, and if this is your pressure atmospheric and this is your pressure due to piston, so during its movement the inside pressure will always balance to this pressure. That means resistance pressure doesn't change. If the resistance pressure doesn't change, so inside the pressure will remain same, so it moving in quasi equilibrium process, right? So we know that first law of thermodynamic for a process, first law of thermodynamic for the process, for the process, what is it? This is your integration 1 to 2 dq is equal to integration 1 to 2 dE plus integration 1 to 2 dW, right? This is for a process. Now if we integrate it and find the total heat transfer during a process 1 to 2 is equal to change its total energy E2 minus E1 plus total work transfer during process 1 to 2. So for simple compressible system and for a stationary system, what is that? This is your, if you combine this, then E2 minus E1 is equal to U2 minus E1, right? your concept of internal energy. Okay, now if it is like that, so for that, if we put here Q122 is equal to U2 minus U1 plus 1 to 2 PDV. Why PDV? W1 to 2 is equal to integration 1 to 2 PDV. Why? Because quasi static equilibrium, right? Quasi static equilibrium and simple compressible substance, right? Okay, now if it is like that, so what is the value of integration 1 to 2 PDV? This is nothing, this is your P2 V2 minus P1 V1, right? So what is Q1 to 2 is equal to, if we take U2 plus P2 V2 minus U1 plus P1 V1, you may write like this. Okay, where U plus PV is nothing, it is equal to H, and U is the property, P is the property, V is the property, so this is a property. This is your system property. System property called enthalpy, right? So it is a system property, so enthalpy will not depends on process of the path, right? So it is not depends upon the process of the path. Okay, so we can write like this: Q1 to 2 is equal to H2 minus H1, and this is equal to delta H, change in enthalpy. So change in enthalpy is equal to heat transfer at pressure constant, right? So you must be here know that there is many confusion for many students is like that. They say that, sir, change enthalpy, it is always at a constant pressure. No. So here one note here, this is very big confusion. One note here, what is that? Enthalpy is not only valid for constant pressure process, because it is property, right? And for any system, and sorry, and for any process, right? But this change, that means change in enthalpy, change in enthalpy at pressure constant is always gives heat transfer, right? This is a very important information about enthalpy. So see here, you must know about in this manner. What is that? There are, if so, up to this there are two properties. One is the internal energy and one is the enthalpy, right? So what is the internal energy? Let's suppose U is the internal energy and H is the enthalpy. So what is the common? Both are properties. Number first, and if the change of internal energy delta U is always Q minus W. That means net heat transfer minus net work transfer, right? So this change of internal energy for any process, this is for any process. Why? Because it is a point function. It depends only initial and final state of the system. It is not depends upon how the process taking place from initial to final state. Likewise, the change in enthalpy, what is that? H2 minus H1. This is also a properties. Why? Because it depends upon initial and final state of the system. It doesn't depends upon what process will taking place from initial point 1 to 2. But if but if this change in enthalpy, if this change in enthalpy at pressure constant always gives heat transfer. Likewise, change in internal energy always gives difference between net heat transfer and net work transfer. This is very important, I'm telling you. This gives only heat transfer at a constant pressure, but this gives difference between heat and work transfer for any process, right? Okay. And what is the specific, what meant by the specific? That means specific enthalpy, specific internal energy. Specific matlab property per unit time. If you say that a specific internal energy, what is that? That means a small u is nothing total internal energy divided by mass of the system. Like that, a specific enthalpy. What is that? Small h is equal to capital H by m. This is the total enthalpy of the system. And what is the h? H is nothing. It is your u plus PV. That means this is your u by m divided plus pressure into volume by m. So what is the specific enthalpy? H is nothing. It is your specific internal energy plus pressure into a specific volume. So this is your property, and this is your property, and this is your property. So it is a property. So what is that? What is the enthalpy? Enthalpy is nothing. It is U plus PV. But if someone you ask what is the change in enthalpy, first you ask, someone asks that the change in enthalpy is exactly gives, that means, so someone asks you like that, this is a question mark, change in enthalpy is equal to heat transfer at what process? Only pressure is constant. But if the change in enthalpy for what process? It is any process. But change in enthalpy is equal to heat transfer only for pressure constant. Right? Okay? Okay, thank you very much.